The last expiration policy that we will cover is version-based cache expiration. And in this policy, we assign some data versions to cache entries, and the entry is refreshed when a new version is available. So the expiration is based on the versions of that entry. How it happens? So we generally associate a version number with each cache entry. And whenever an update occurs in the original data source, let's say the database, that version is incremented. And after that, whenever we access the cache to get the entry, first of all, we check the version of the cached entry. We compare it with the version of the source. And if it is outdated, the entry is considered expired. So there is this version involved and the comparison between the cached entry and the source. This kind of expiration can be used with documents or configurations. So let's say we are working with some documents, because documents generally have a version number. Whenever we do some changes in the document, it creates a new version. So whenever a document is updated, the version would be incremented. At this point, the cache is not updated. It doesn't know anything about this update. So it has an entry with an old version that can be now expired. So that's how version-based expiration works. So this policy is suitable for scenarios where we can maintain the versioning, like documents or configurations or anything else where we can have the clear version information. This is also effective in distributed caching scenarios, because in such scenarios we have multiple cache instances and each cache instance has its own set of data set. So we need to maintain the coherence between all these instances. And we can use version-based expiration to maintain that balance, because when different cache instances have different versions of the same dataset, we may choose to update the replicas or we may choose to expire the entries which are outdated. All right. So let's quickly see a sample implementation of this policy as well. And I will point it out again. This is not a complete implementation. This is only a pseudocode. Here we have a similar entry class, and this entry class this time has two attributes. One is the data and the second one is the version information. In this example, we are using the long data type for version, but in reality, it could be anything. It could be a timestamp or any other data type, as long as it conveys the information of a version. All right. If we check the cache, so in the get method, before the cache returns the entry, first of all, it will check the version of the cached entry and the source. And let's say if the source has been updated and it has a greater version, that means we need to refresh the entry. We need to mark it stale. All right. So in the refresh method, you can see we get the updated data from the source. We update the entry with that data, and we also update the version which is coming from the source. So we compare the versions, and based on that comparison, we mark it stale and refresh the entry. So this is only a small implementation to explain the fundamental concept. There are some important considerations in this policy. If we are using this policy, we should have an efficient mechanism to correctly maintain the versions, because it's dependent on the version information. And whatever mechanism we choose or implement, it should be able to quickly update and check the version information, especially in the high throughput system. Because if we are spending too much time on updating and checking the version information, then it would decrease the throughput and it would increase the latency of the system. And we must also ensure proper concurrency management to avoid race conditions when we are updating the versions or when we are checking the versions. Because in real life, there would be concurrent data updates on the dataset. So just to summarize, this expiration policy ensures that the cache remains synchronized with the original data source. And by using a version number with each entry, it can quickly determine whether the cache data has become outdated and needs to be refreshed, or it is in sync with the original data source. And that concludes the discussion on the cache expiration policies. We discussed time-based, idle time-based, and version-based time expiration.